Where we stopped yesterday was y'all were going to finish this for homework. So the axis of symmetry and the x-intercepts of concavity, vertex, and y-intercept for each of these forms and how we're going to find it. This page here is our one-page sum up that we're going to keep throughout the year. Or I guess technically it's a two-page summary because it has front and back and forth and front of the other. But let's take each of these, and so let's look at the standard form first. So in standard form, that's when everything's all multiplied out, and we can find our y-intercept by 0, comma, your c value, which remember c is this number that's added or subtracted from the end. You can find your concavity by your a number, the number that's multiplied times your x squared. If your a is greater than 0, it opens up. If a is less than 0, it opens down. And the same is going to be true as we go through each of these forms all the way through it. Now, let's go through the ones that aren't so straightforward. So those two are the two easy things that you can identify from the function. And we are needing to find axis of symmetry and x-intercepts. So let's go through axis of symmetry first. This is x equals negative b divided by 2 times a. So remember, b is this number here, and a is the one that we found opens up, helps us open it up or down. Then you can find your vertex by taking that same number, negative b divided by 2 times a, and then to find the y value, you're going to plug that number in for x and to find y. X-intercepts. X-intercepts so far, the things we can do to find x-intercepts is we can use the graph or graphing utility on your calculator. You can factor, and so those equal to 0, and then find your x-intercepts. Something that we'll be adding in later is you can use a quadratic formula. We're going to go ahead and add it to our list because I want you to have it on here for the whole summary and not have to remember to go back and put it on. So let's go ahead and go on to the next one. This next one is in factored form. So when it's in factored form, we can still find that concavity. If it's greater than 0, it opens up. If it is less than 0, it opens down. And you can still find one other piece of information. In this case, we can find the roots easily from this piece. And so our x-intercepts are 0, comma, excuse me, I said that backwards, R1, comma, 0, and R2, comma, 0. And remember, when you're bringing these down, these are going to come in opposite of what you see in the paper because there's that minus sign in the formula. Now, to find the axis of symmetry, it's going to take some math, and some math that you'll have to do is your x is going to equal your R1 plus your R2 added together and divided by 2. For your vertex, it's going to be very similar to how we just said we would do it. We're going to take that x value from above, and then we're going to plug it in to x to find y. And then your y-intercept, this one we're not going to be able to just tell from the paper, so we have to actually do some calculations. And to find your y-intercept, you will take and plug in 0, 4x, and that will give you the y. And so that number will be 0, comma, whatever you come up with for that. That is the factored form. The last method that we have is vertex form. Again, your concavity is that A. If A is greater than 0, it opens up. If A is less than 0, it opens down. And for this one, you can easily find your vertex by H, comma, K. And when you find H, remember it is opposite of the sign that you see up there, and K will be the same sign that you see. And so when you find your axis of symmetry, it's opposite of whatever sign you see for H. Now to find your x-intercepts, you could graph it, just like we were saying earlier. You could, this time we'll have to multiply, so we'll use that box first to multiply. Then you're going to have to do factoring with the box. Or you could use the quadratic formula. And then to find your y-intercept, you're going to plug in zero for the x to find the y. And so 0, comma, whatever that number is that you find. Let me do this. And so that's going over those 3 charts. And so make sure to have those in your notes, because you can use those throughout the year when we're having to go back and refresh and pull information from here. But now we're going to take and write our equation or our function. We have up to this point been taking the information from the function. Now we're going to go back into it. So we have George and Pat. Each of them know that the vertex is at 4, 8, but they're not given any other information. So they both have the same vertex. They have different A's. And so they're not going to graph the exact same thing. So A for George is -1/2. That means it is opening upside down and it is a vertical compression on it. So it's going to be a little bit of a fatter graph on George's. Pat has a of 1, and so it's opening up and there's no stretch or compression on that. But we talked about that we can't make a unique quadratic function unless we have either a vertex and another point or 2 points. And so here is where we can do this, where we're given the vertex and we're given another point. And so y'all are going to write the quadratic function given this information. So since we have the vertex, we're going to use vertex form to start off with and fill in what I can. X minus my h value squared plus my k. Remember, this is h and this is k. Now, that doesn't get me to where I know what a is. So I need to go one more step. And we're going to plug in that extra point. So this point is x comma y, but there's not a y over here. Remember, this is y. So 9 equals a times 4 minus 5, that quantity squared. So 9 equals a times -1 squared plus 2. And so 9 equals a times 1, because negative 1 squared is 1, plus 2. So I'm going to move that 2 over by subtracting to move it. A times 1 is a. So our a is 7, and I'm going to take that up here and replace. So my equation, my function, is f of x equals 7 times x minus 5 squared plus 2. So this is the quadratic function given this information. Now, if I am trying to write the quadratic function, but I'm given roots instead, that means I need to use the factored equation. And so the factored equation is f of x equals a x minus root 1 times x minus root 2. So f of x is equal to a, because I still don't know that one, x minus root 1. So when I do the opposite of that, it becomes 2. And then x minus opposite of this, so x minus 4. Now we're going to take and plug in our other point into the x and y. And just remember that this is y. And so we're going to plug in 6 here equals a times 1 plus 2 times 1 minus 4. And so we have 6 equals a. 1 plus 2 is 3. 1 minus 4 is negative 3. So a times negative 9 equals 6. Well, I need to divide both sides by negative 9 to get it solved. And so when I reduce that, I end up with negative 2/3. So there's my a that's going to come up here and replace. So my function is negative 2/3 x plus 2 x minus 4. Now, I want you to take time and think through this one, even though I just gave you the answers on all of these. We need to figure out which form is the best one. And so when you're looking at this, minimum point is vertex. And then the other one that we have that's vertex, if you look at this, you're going to see that this reaches the maximum height, so that's another vertex. And so those are our two vertexes. So those are the two that need to be in vertex form. Now, for factored form, we need to look for when it crosses the x-axis. So your x-intercepts, your roots, another name for it is your zeros, or it may be written this way. Those all go best in factored form. Now, looking at the last two we have, these two have 3 points. And so in this one, it's best in standard form. But when I'm looking down here, I notice that every single one of these has a y value of 3. So this one's none, because really the best equation for it is y equals 3. So that constant graph, that linear graph, is the best for D. So you're going to take this information and you're going to write your quadratic function for, given that the vertex is here, at -3, 4, and the point is at -4, 1. So you're going to use the vertex and the point to help find the equation. You should have found the equation as -3 times x plus 3 squared plus 4. And so if you need to see the work of how you do that, it's over here on the side. So we're writing the quadratic function. We're given the vertex on this one and 1 and 2 intercepts. There are 2 different ways you can do this one. You can either go through the factored form or you can go through the vertex form. Your choice, but just make sure if you're doing the factored form, you find the other x-intercept before you start. So if you did the vertex method, the black is the one that would actually give you the process, and your equation would be 2 times x minus 3 squared minus 2. But if you did the factored form, you would go through and you still would get a 2 for A, but it's x minus 2, x minus 4.